Hi everyone, I'm Sneha and I'm excited to present our project titled Fine-Tuning Llama-3-8B-Instruct for Tutoring. LLMs like Llama-3-70B have demonstrated exceptional performance across diverse tasks, but the deployment requires significant computational resources. In this study, we explored the potential of fine-tuning a smaller model that is Llama-3-8B-Instruct for SAT exam tutoring assistance. Our objective is to investigate whether a lightweight model like this can approach the tutoring quality of much larger models like Llama 370B with the help of carefully designed and domain-focused training examples. Our motivation is quite simple. Can we fine-tune a much smaller, cost-efficient model to deliver comparable educational support? Our methodology consists of several carefully designed components here. You can see the flow chart. Yeah, I will start with the first step. We began first by focusing on the reading section of SAT, breaking it down into 19 conceptual categories. We curated a data set of 95 questions, 5 from each category. These were directly sourced from the official college board materials to ensure quality and difficulty balance. To structure the model's thinking process, we constructed a Neo4j knowledge graph using AutoDB. Each question's graph contains main ideas, supporting and misleading details. These are basically the nodes and relationships between the nodes. So these were linked via meaningful relationships like supports, misleads, explain. This can be seen in the demo part of my later video. This graph played a critical role in building the prompt while applying to LLM. So when a student, we also developed a front-end web page through which a student can interact with the chatbot. When a student enters a query in the front-end web page, this will dynamically retrieve the corresponding questions related nodes and the edges, and those will be retrieved and passed to the prompt to the LLM. So this is what we call it as a stage of prompt construction. And also, like we have built a backend fast API server to connect this chat interface to the LLMs. And for find the prompt from the prompt construction stage is passed to the LLM for inference in two ways. Like one is through the standard Llama 370B model through Grok inference engine, and another one is what we are aiming at, that is fine-tuning Llama 3-8B Instruct model. We have fine-tuned with the help of our training examples where we created a kind of dialogue conversation between a student and teacher, and such samples were given as a training data. We have frozen all the previous layers and we have just updated the weights of the attention layers of this model, and those changed delta weights are matched back into the base model Llama 3-8B Instruct. This was all done in the run pod infrastructure. We have also created a backend fast API server which exposes this endpoint to interface with our front end. So yeah, both the responses from the standard Llama and the fine-tuned Llama were collected and stored in the MongoDB here, so that it can be used as a reference for the future or retraining purposes. And then the next stage is evaluation, which will be explained further by my teammate Udit.
Hi, I'm Uditanshu. So let me tell you about the evaluation steps that we did. So to access the effectiveness of a fine-tuned Llama 3 8 billion model, we designed a controlled side-by-side evaluation comparison with the Grok-hosted Llama 370 billion model to determine how well a smaller fine-tuned model performs in SAT-style tutoring scenarios, especially in dialogue-based real-world interactions. We crafted 15 conversational questions grouped across 3 SAT reading MCQs. Each MCQ was followed by 5 realistic tutoring style follow-up questions. This setup simulates how a real-world student might engage with an intelligent tutor. Each of these questions was paired with an original SAT passage, a selected answer, a structured prompt generated using graph-based context with Neo4j. The model that we compared for our use case are Grok Llama 370 billion model, which is hosted by a Grok's inference engine, known for high-speed LLM responses, and fine-tuned Llama 3 8 billion model, a 4-bit quantized model using LoRa, fine-tuned on SAT-style Q&A and hosted on RunPod. Each prompt and user query was passed to both models, keeping everything else like context, format, and history identical. We use GPT-4o as neutral judge, instructed to compare both responses blindly and independently on 3 dimensions: comprehensiveness, diversity, and empowerment. Judging was performed using Likert scale from 1 to 5 for each matrix. On comparing the performance of both these models, we got to know that both Llama 370B and fine-tuned Llama 3-8B produce coherent, context-aware responses when provided with structured knowledge graph prompts. But in comprehensiveness, Llama 370B consistently delivered higher comprehensive answers. However, fine-tuned Llama 3-8B model, despite being smaller and 4-bit quantized, shows surprisingly strong coverage in addressing question context, often achieving comparable score. As for diversity, the fine-tuned Llama 3-8B exhibited good reasoning diversity within the limited scope of the fine-tuning dataset. Llama 370B naturally showed more nuanced perspectives given its larger pre-training scale. And in empowerment metric, both models effectively supported learner understanding, but the fine-tuned 8B model responses were found to be more concise, direct, and tutor-friendly in several cases. When quantifying the insights, we got to know that evaluating using a 5-point Likert scale, the fine-tuned Llama 3-8B often score within 1 point difference of Llama 370B across matrices. In such examples, student perceived helpfulness was even higher for the fine-tuned model due to its simplified and encouraging tune. Key takeaway here was with careful fine-tuning using high-quality structured dataset, smaller 4-bit quantized model like Llama 3-8B can approach performance of much larger models, offering a cost-efficient and deployable alternative. We plan to refine our work in future by scaling across different subjects, as currently our work is focused on reading section questions of SAT. Future extensions include incorporating math sections of the SAT, requiring knowledge graph structuring for formulas, math strategies, and problem-solving steps, making the system scalable across broader exam preparation. We also plan to enhance dataset size as fine-tuning on a much larger, carefully curated database across multiple concepts and difficulty levels could further close the performance gap between smaller models and larger ones like Llama 370B, and extend the system to include video transcripts, diagrams, and images alongside text to make a richer, multimodal learning experience for SAT students, improving comprehension and engagement. Now, Sneha will give us a demo of our project.
So here, this is the question we are trying with our chatbot. And these are the options. I have selected something at random. So I have started conversation with my tutor saying that I'm confused between C and D. Help me with this. So it has said, I also instructed it not to tell any answer. I want to solve it on my own. It does that exactly. It didn't reveal any answer, but instead it guided me in arriving at the correct answer choice. And then I have continued my conversation saying, what do you think is the best way to answer these kind of questions? So now I will just ask it, okay, then what's the right answer? So yeah, it has shown the correct answer. It's the option B. Right now, this chatbot is using the fine-tuned Llama 3 7 billion parameter model, which is fine-tuned with the dataset curated by our team. This is my Neo4j RODB screen where I have created the questions as nodes and edges. Here you can see that I have retrieved one question just to show you how it is connected to all the different nodes. The center one is the question. It has these attributes here, and it is connected to like which concept does it belong to, and what's the main idea of this passage, and what are the things which are details available in the passages supporting this main idea, and what are the things which are distracting this main idea. So all these things were supplied as a nodes and relationships semantically in this Neo4j graph DB, and whenever a user enters a query in the chatbot, that will be converted into the cipher query here, and the corresponding like all the things which are connected to the central question node will be supplied as prompt to the context window in LLM, and that's how this helps in building the prompt.